We will move on to the next section, principles of operation. Okay, let's start with one example and see what type of input outputs we have and how we could program based on ladder logic program. So here we have a mixer motor. So here is a mixer. A mixer motor is to be used to automatically stir the liquid in a vat when the temperature and pressure reach preset values. So here is vat, okay, and we want to stir this liquid here when the temperature, we have the temperature sensor and the pressure in this one, pressure sensors, these two, okay, reaches to preset value. Or we could have manual operation of the motor, which is provided by means of a separate push bottom station. Okay, so we want to have two modes of operation: automatic mode based on the sensor inputs and or logic. The second mode of operation is the manual mode, and the operator should be able to start the motor by pressing the push button. Now we want to see how we could control the motor by hardwiring relays and contacts. So here we have two pressure switch and temperature switches. We could put them in series. If the pressure reaches to the preset value, then this contact will be closed. Or if the temperature reaches to the preset value, then this contact also will be closed. And then the circuit will be closed here and the motor will be started. What is the voltage on this circuit? 120 volt AC. Okay. This one is overload contact relay. Okay. It means that if the motor is overloaded, then it will basically disconnect the circuit and the motor will stop. Okay, so for the sake of simplicity, for now, just ignore this overload contact and think about these two contacts or switches and the motor starter. Or on the manual mode, if you press the manual push button, then the motor should start. Okay, so we have two branches. These two branches are in parallel. Either this branch, either this logic should be hold true, or this one should be hold true, then the motor will start. Now basically we use the same methodology, we use the same wiring in our relay or in our ladder logic programming language. The motor starter coil, or M, is energized when both the pressure and the temperature switches are closed, or when the manual push button is pressed. Okay. We continue with PLC method for control of motor. The same input field devices, pressure switch, temperature switch, and push button are used in PLC. Okay, so in the previous slide we had relays and switches instead of a PLC. Now we want to use a PLC. So we need to connect our input devices to the input module. So here you could see how these devices are connected to the input module, and you see what is the voltage here. For the output device or motor starter should be connected to the output module. And now we need to program our PLC. And this is the ladder logic program that we need to download into the memory of the CPU. So you see that it's very similar to the hard wiring of contacts and coils. So here we have our pressure switch, temperature switch, manual push button, a motor starter coil, and here we have our input devices connected to the input module, and the output device is connected to the output module. The symbols, okay, these symbols, okay. The symbols represent instructions and the numbers represent the instructions addresses. So these are the numbers, okay. So this one is connected to the first input of the input module, okay. So it's input, that's why it starts with I, and it's connected to the first port, so it's I1. So in our programming, we just need to refer to the address. So when we use I1 contact, now the program knows we mean, for example, the pressure switch. Each input and output device is given an address, which lets the PLC know where it is connected. And this one, the motor starter, is O1. O because it's output, and 1 because the motor is connected to the first module of PLC, the first port of output module of PLC. We could have one output, let's say one motor, but that motor connected to, let's say, the second port of the output module of PLC. Then inside our program, we have to use O2, okay? Okay, for the program to operate, the controller is placed in the run mode. So we usually, in PLC, we have a run, pause, stop button. So we need to have that button or switch on run mode. Now PLC starts scanning. During each scan, the controller examines the status of input devices, executes the user program, and changes the output accordingly. Okay. The coil O1 is energized when contacts I1 and I2 are closed, or when contact or we have parallel branch, so it's or logic, or when contact I3 is closed. Okay. Either of these conditions provides a continuous logic path. So continuous logic path across the rung. Okay, so either this one, a continuous logic path, or this one. This is the path across the rung that includes the coil. Okay, so if we press the push button, we will have a continuous logic path across the rung. Okay, typical wiring required to implement the process control scheme using a fixed PLC controller. So for the fixed PLC controllers, we basically use almost the same method. We just need to connect the input and output devices to the input and output ports. You see the input ones are represented by I1, I2, I3, and the output one, Q. They usually use Q instead of O uh, because to avoid confusion with 0. Okay, because if they use O, that O could be mistaken by 0. To avoid that confusion, they usually use Q instead of O for the output. So we have Q1, Q2, Q3, Q4, but in this case we only have one output, which is the motor starter and is connected to the Q1. So here you could see the program, the ladder logic program, which is downloaded to the memory of these fixed I/O PLC controller. The next section of this presentation is about modifying the operation. One of the important features of a PLC is the ease with which the program can be changed. Original hardwire process control circuit could be modified, and change requires that the manual push button control be permitted to operate at any pressure, but not unless the specified temperature setting has been reached. So in this example here, we see that we could easily change the program. So now we could only override the pressure sensor by the manual push button, but the temperature should be reached to the preset value. But if we use relays, we need to change the hard wiring of the system, and it would be more difficult than using a PLC. If a relay system were used, it would be required some rewiring of the circuit. If a PLC system were used, no rewiring would be necessary. The inputs and outputs are still the same. All that is required to change the PLC ladder logic program. So we are using the same sensors and we are using the same motor, so we don't need to change the wiring if we use PLC, but we could just change the program easily and download it to the memory of PLC. PLCs versus computers. The architecture of a PLC is basically the same as that of a personal computer. Unlike PCs, a PLC is designed to operate in the industrial environment with wide ranges of ambient temperature and humidity. Okay, so we could have high humidity, dusty environment, high vibration, but still those PLCs will operate on time, will do the scanning, read the inputs, and update outputs. A properly designed PLC installation is not as affected by the electrical noise inherent in most industrial locations. So we have a very good electrical isolation in PLCs, and that's why PLCs don't or won't get affected by ambient electrical noises. Unlike the personal computer, the PLC is programmed in relay ladder logic or other easily learned languages. The PLC comes with its program language built into its memory and has no permanently attached keyboard, CD drive, or monitor. So we use either ladder logic or other type of intuitive programs to program PLCs. So we don't use, let's say, C++, I don't know, Sharp, Python, these type of conventional um, programming languages. We use different type of languages. Computers are complex computing machines capable of executing several programs or tasks simultaneously and in any order. But on the other hand, PLCs execute a single program in an orderly and sequential fashion from first to last instruction. Okay, so here you could see one of the sequential flowcharts that it basically monitor inputs, execute program, and changes output, and will back to the first of the instruction. Yes. PLC control systems have been designed to be easily installed and maintained. Troubleshooting is simplified by the use of fault indicators and the messaging displayed on the programmer screen. Input-output modules for connecting the field devices are easily connected and replaced. Okay, so this is another differences between PLCs and personal computers. The troubleshooting is simplified. We have lots of indicators to show the status of the machine, the status of inputs and outputs. And we could easily increase the number of input ports and output ports in case we use modular PLCs. Software associated with the PLC but written and run on a personal computer falls into the following two broad categories. The first one, PLC software that allows the user to program and document, gives the user the tools to write the PLC program using ladder logic or another programming language, and document or explain the program in as much detail as is necessary. Okay, so you see basically here, you could document it, you could add comments, you could name specifically contacts and coils. PLC software that allows the user to monitor and control the process is also called a human-machine interface, or HMI. So here you could see one example of these HMI panels. It enables the user to view a process or a graphical representation of a process on a monitor. So first, we could monitor the process, yes? What is the status of one input? What is the status of output? What is the status of a process? Second, determine how the system is running, print values, and receive alarm conditions. Okay. Plus, we could apply some changes. We could, for example, press a button on an HMI and apply some changes, or start or reset or stop, or for example we could have some alarm indicators on the PLC and see what's happening on the process. Programmable automation controllers, PACs, combine PLC ruggedness with PC functionality. So we use durability of PLCs and we could have at the same time functionality of PCs. Using PACs, you can build advanced systems incorporating software capabilities such as advanced control, communication, data logging, and signal processing with rugged hardware programming logic, motion process control, and vision. PLC size and application. The criteria used in categorizing PLCs include functionality, number of inputs and outputs, cost, and physical size. The I/O count is the most important size factor. In general, the nano is the smallest size with less than 15 I/O points. This is followed by micro types, 15 to 128 I/O points, medium types, 128 to 512 I/O points, and large types over 512 I/O points. Matching the PLC with the application is a key factor in the selection process. Okay, so basically we use we look at our application, we see how many input and outputs we have, and based on that we use appropriate type of PLC. If we use, for example, a large type, once we have 15 I/O, we just increase the cost of PLC without any specific reason. There are three major types of PLC application: single-ended, multitask, and control management. A single-ended application involves one PLC controlling one process. Okay, which is basically, in most of the cases, we use a single-ended application. A multitask PLC application involves one PLC controlling several processes. Adequate I/O capacity is a significant factor in this type of installation. That one is not as common as single-ended PLC applications. Usually we use one PLC for one process. If we have more than one process, we use basically one PLC for each of them, and we'll establish a communication between PLCs. Like this one. A control management PLC application involves one PLC controlling several others. So we have several PLCs, and those PLCs are controlling one process each, and then we establish a communication by, let's say, a control management PLC or central processing unit. These kind of application requires a large PLC processor designed to communicate with other PLCs and computers. The control management PLC supervises several PLCs by downloading programs that tell the other PLCs what has to be done. Memory is the part of a PLC controller that stores data, instructions, and the control program. Memory size is usually expressed in K values, let's say 1K, 6K, 12K, and so on. The measurement kilo, abbreviated K, normally refers to 1000 units. When dealing with computer or PLC memory, however, 1K means 1024, because this measurement is based on the binary number system, which is basically 2 to the power of 10, which is equal to 1024. Depending on memory type, 1K can mean 1024 bits, 1024 bytes, or 1024 words. The amount of memory required depends on number of I/O points used, size of control program, data collecting requirements, supervisory functions required, and future expansion. The instruction set for a particular PLC lists the different types of instructions supported. So here, for example, in this table, we have typical PLC instructions. For example, XIC, examine a bit for an on condition, or XIO, examine a bit for an off condition. I don't know, timer on delay, timer off delay, count up, count down. We will basically understand all of these instructions in coming sessions, and we will use them. Okay, we are almost to the end of lecture 2 presentation. If you have followed these lectures, then you should be able to define the programmable logic controller and mention its advantages, identify main parts of PLC, outline the basic sequence of operation for the PLC, identify the general classification of PLCs. Okay, before finishing this lecture, I want you to follow these instructions and install Codesys software. We'll use Codesys software throughout the course of this program, this course, and I want you to go to the following address and install the Codesys. So as you could see, once you enter to that page, then you could go to product and services and software tab, and go to the following address and click on the Codesys software link. Here you are. This is your Codesys software. You could be able to basically select a product group which you want. I want you to use Xsoft Codesys, and you could also select the product version, use 3.5.4 or higher versions. And then you need to download it and install it. And finally, you need to download and install the program.